Our topic today is the Cartesian plane. Now, to give you a little bit of history of the Cartesian plane, back in the 17th century there were two well-known and very brilliant mathematicians named René Descartes and Pierre de Fermat. And these two guys at the same time, but in different countries, came up with the concept of the Cartesian plane, or the number plane, or the coordinate plane. And this concept actually unified several different parts of mathematics and made mathematics, gave it a bunch of different ways that it could sort of advance. And while this looks fairly simple in some ways, or some might say boring, it's actually very critical to a lot of things that we do today. For example, anything related to computer games or computer dynamics that have to do with graphics and that sort of thing, they use the number plane or the Cartesian plane in order to do that. Cartesian was named for Descartes. That's where the name came from. Now, you'll notice that really the Cartesian plane is just like two number lines that are put together. So this number line is just like a typical number line that you see, and we call this the x-axis. And this number line is basically just like a thermometer, and we call it the y-axis. And as you can see, our number lines have positive numbers to the right or up, and negative numbers to the left or down. And anytime we want to identify any point anywhere on here, then we have that point has what are called two coordinates. So let's say, for example, that we pick this point right here. That point will have two coordinates, an x value and a y value, and we do them alphabetically to help it make it easy to remember. So the x value is 3. We put them in brackets or parentheses, and we put a comma between 3, and the y value is 1. So that's 3 and 1. Okay? And the number at the very center, right here, this is 0, 0, which we call the origin, or we often refer to it with just the letter O. That's the origin, where everything starts, basically. So let's use some examples of what we might do here. Let's say, for example, that we picked this point. We'll start with a nice easy one. We'll pick this point right here. Remember, we do the x first and then the y. So x gives me 1, and y also gives me 1. So we have 1, 1. That's that point right there. Now what if we had a point down here somewhere? Let's say we had this point right here. Again, we start with the x value. So we start at the origin, that's what the origin means, and we go this way to 3, and we go down to -2. And that's that point. How about if we pick one over here somewhere? Let's take this point right here. So again, we do the x value first, how far from this direction, and it's -2. And how far this direction gives me -4. And we'll do one more in this example. Let's say we pick this point right here. That's going to give me -3, because if I'm over here, and 3. Now we can work these, of course, the other direction. Let's say that I ask you where the point, right over here, the point 2, 3, where would that point be? We take the x first, 2, and we go up 3, and so this point right here gives me 2, 3. How about if I wanted -4, -2? Well, we start with -4 in the x direction and -2 in the y direction, so that gives me -4, -2. Or maybe we want -5, 1, -5, 1, or we'll do one more. How about -4, 3? Excuse me. Do it the other way. 3, -4. Well, we would go 1, 2, 3, and down to -4, which would give me 3, -4. That's also helpful to remember sometimes, although this is not terribly important yet. We talk about the number plane in 4 pieces, or 4 quadrants. quad meaning 4, so there's 4 parts. And when we do that, this is the first quadrant where everything is positive, and we go in an anti-clockwise or counterclockwise direction. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And that is the Cartesian plane.